All right. I want to tell you one thing. I had my meeting with Munzer, and he said, okay, Amir, you are coming and saying you have this B function and R function and how it works. This is your assumption, this is your model. And something very interesting I heard first time was that what is the best data set, perfect data set that confirms your model? In reality, we have the data set from a platform. We try to have a model that works with it. He said, if you have this model of user behavior that they select the maximum RIB pi I going through the list, what is your what is your what is a data set that kind of confirms it? I want to get back to this, but we were in the middle of something more fun and I want to continue that, but I want to add a note here. 6 um, 8 what is the perfect data set for B of pi I Ri? We will get back to it. Let me clear some of this stuff as well. Causal inference. All right, let's go finish our mechanism design framework. So we said either we should choose another utility function for the platform, or this will be like if we assume that for each intention items are homogeneous and we have a ranking for them already, we can compare and value each product for a more general query. And then we said, all right, this is the ranking we will end up with, and okay, now I don't like DCG because in our model we said our users have an eyeballing cost and well, we can say we are trying to maximize DCG. Eyeballing cost, and another one was eyeballing is through the list, and another one is a specification cost, how much it costs them to type completely what they want, their intent, right? AQ is eyeballing cost, EQ. AQ and EQ. All right, here in the work we did today, we didn't consider AQ articulation. All right. And biomechanism is a mixing strategy. We ask for query and we mix it and it costs them. But we can say articulation cost is separate from eyeballing cost. Okay, let's get back to our note. I think we're not missing big anything. Question based on users' click behavior. How can we find the prior? Now that we have the mixing model, it is based on these comparisons for each queue. For each queue, we say for each queue mixing rule for, sorry, got an email. For each queue, right, at rank I, we should put argmax on J product that, what is it? Theta Vj, sorry. And J is, okay, f of J says the category, theta f v of fj, r v fj of j, and j in 1 to m minus 1 odd items that already have been selected. 1 to j minus 1. That's the way we want to go. And how does it affect theta now? How does this affect theta? What does it, how does it? Oh, okay. Question is based on user click model. How can we find the prior? Still, I'm not taking into consideration the articulation cost. So let's say we are at Q, like very general Q. The problem with this one is that if user is of type, for example, V1, he always picks product 1 from that list right away. Right? He chooses the we are already assumed that they are sorted based on, for homogeneous products, they are already sorted based on the relativity that maximizes DCG. Or any other metric we have. So the Q will be let's forget about the articulation cost and assume just user searched Q. All right. And Q has 4 like size of V's for if a user clicks on one item, it definitely means that it belongs to that clan. Oh, the effect of boost. So here we just assume relevance, but what about the effect of ranking? That's the important part missing. So I said here, what is the DCG? Yeah, we are removing the effect of boosting. The effect of boosting doesn't matter when we are choosing to put what from which category at that position. But it matters when in a new ranking. So what about it? Yeah, something is missing. We are showing this rule to consumers. For example, with probability theta V1, how can we update these theta? Okay. Let's separate them, right? Let's separate them. We have another thing that, this is another question. This is a forward question. I think separating helps isolating them. We have a list. This list is made of products from different categories. All right. How can we find these thetas of each category, each category? So user clicks on item J, right? Sorry, item pi j in, and J is, for example, in VK, category K. On the list is chosen. What it means is, first of all, I need to have a talk. Dude, Munzer didn't let me finish my model. Also, our mechanism design needs to have the Q, um, articulation cost. And it needs to have, which is minus AQ. That's so simple. We can also assume not DCG, but how deep he wants to go. Well, in Nagin's model also we had the cost as a sigma scar, which is a valid cost. As the user, if you want to set it mechanism design, first stage I should choose the Q, and it costs me the articulation cost, and then let's assume we have some sort of mixing. Then we choose given I called it R, right? R of Q. Um, Given R of Q, how deep I should go. So it will lead to eyeballing cost, EQ. And if we are saying there is eyeballing cost, then we can just say we are on a utility. And EQ is function of the rank is a function of rank item pi I. So our cost, our utility will be the gain we get Ri minus EQ, how deep it is of pi I minus articulation cost of Q. That's one thing we can. Actually, I should say eyeballing cost. Eyeballing cost we assume that is independent of which layer of the graph we are. Well, we can say it's, but let's assume it is indifferent and it just depends on the position. But your ranking depends on Q, and actually is R of Q. Utility for item I will be this. Only depends on position. And then max on I, Ri. Well, I should say R of I and V, right? Because R of I and V minus eyeballing cost R of Q. RQ is the list we give to you. Pi Q. I can say pi Q, alright. Pi Q of item I we can say articulation cost also depends on the type. Given your type V minus AQ, right? We need to settle with one of these models. If I in AV, then this equals R of I minus RV of I. Yeah, let's set a model. I wanna give them two models, and then they say, okay, I don't like this part of the model, and I fix. Minus AQ is easy. Can we have it in a truthful manner? This is the utility you get. So for your type V, given your type V, you come with a function Q of V that maximizes this thing, R of I. Why is it item I? Yeah, item I of V. Item I. That's it. Item I is item I. I is the item, not the position. We know the rule for pi q. We know the mechanism. We know the rule for any q. We know what is the pi q, right? We are the user. We set the v. We know what is the pi q. And if I say this q, it will be this. And item I will be located at this position. Alright, it will be located at this position. It will cost me it will cost me I know my intent is this. I know how the mechanism works, and I want an item. Also, let's assume that assumption congruent ranking. If I and j like q prime, if it is in q, and pi q prime of item I, and I and j also, I and j in v av, and v in q prime in q, pi q prime of I, pi q, actually pi v, we have I, pi v of j. Item I has a better ranking when we are clear. Then for each q, pi q of I less than pi q of j. What it means? What it means is like R, I, V, because articulation costs for both of them are similar when we search V, minus eyeballing cost of pi V of I and V, which is in V, that's right, greater than R J V articulation cost of eyeballing cost of pi V J V, right? Therefore, we can say, can we say this? R So AQ and AQ cancel out, and can we say that if we have this congruent assumption that pi q of I remains pi q of j for any q, well, we need the eyeballing cost, not the rank only. That's where okay, we can say this actually true. Okay, let's assume if for one category you are topper, for any other query you will stay top. Um, we cannot say that, alright. Actually, we cannot say that. This equation is not true all the time. Depends how far you go. Let's assume I and j are for category V are next to each other. But when we search Q, j drops 10 level. Okay. Can I say this? Ri. Eyeballing cost now. Well, eyeballing cost should change because E is this expectation. Pi and is that true? Eyeballing cost of I don't think it is true. No, that cannot be true. I mean, it depends on eyeballing cost, to be honest. We need to have an N also, that N that user do not go beyond it. So even if you put the best of your product in there should be a threshold. There should be a threshold. All right. So why did I say that? I want to say if I go DCG, he wants to choose item I, and he wants to, there is a queue that maximizes this time. Actually, if we are assuming DCG, we do not need to assume they are choosing we are choosing DCG. If I am choosing DCG and this motherfucker is maximizing our DCG, I wanna see how types are. The question is that once you have how can we find the prior on theta? So I have my list, not even the consumer model. Let's say we have a list. How can we find the priors? I have this list. Look at this, my list. This is my list. This is in V1. This is in V2. Again V1, V1, V2, V3. This is my list. V3. User chooses, if we go again p pi I, user chooses item this I. We had n users, each user clicked on something or didn't click. Clicks on one item or clicks out, right? Which is 0. Item 0 is clicking out. I think we need to have a threshold thing. Threshold. Yeah, I think we need to set it up based on threshold. Otherwise, they can always maximize. By the way, this method does not say when it happens that We cannot think that we have the best ranking for the homogenized items. I think we need to get dirty. Okay, we are getting dirty, but other people needs to join as well. You have one list, you have a click behavior. How will you find the thetas? Consumer, the number of the consumers, choose any of them. Theta v t plus 1 will be in b. We cannot say what is in b. Well, we can say one of those over n, the whole number of things. But does NV change? Does NV change? Each consumer that is from type V finally choose from product V if our list have all of them. If our list has all of them, they finally find the item. So we need to come up with a quitting model. Quitting or giving up model. And that's why threshold matters. That if it is too far, we are not looking at them. For example, EQ, eyeballing cost, E is such a bad name. I say Y. Y of like ranking R, like at rank R, let's say rank J, rank I and J are for the item, K is for the partition and types. Well, V is for the partition. V is for the intent. So, and we have K categories. So let's ij k l l. Let's say L. Y of L rank. Um, is like minus L squared, or if you are going to the RIB of L, then if B of L is less than something, we should stop. Like you should have a nice decrease that max RIBL. Yeah, we need to have assumptions on B. Fast decay. So the user does not go very far. Or we say max of RIBL, and we assume RI is at maximum 1, right? Relevance is at maximum 1, and 1 over like BL. If it is BL, then out. This way we can say that they may not click, even though they belong to that item, they may not click. So we need to have an outside option, definitely. What is outside option? Either it is either it is we need to have an outside option. Either it is that's it. Pretty much. Come up with an outside option. I don't know what is the outside option, but we have to have. So in general, we have like three main problems. We have a homogeneous list, homogeneous. What is user behavior? RIBI. And how good is my model, suggested model. Then we have mechanism design. And mixing room. Sorry, not mechanism design. 2 simpler than mechanism design. 2 is given this pi v prime, and this is q, pi q, how to set this. 3 is mechanism design. 4 is how can you find theta v based on a list of not diverse, but based on a diverse list of items. What is outside option? By the way, I'm down to simplify. That's it. That's the main question. I think the main question is number 2 and number 4. 4 comes later, number 2 and number 3. Yeah, I think I need, thinking further does not help. I have assumptions and I want to see how good those assumptions are. And we need the question 1, answer question 1, in order to have a understanding on how to deal with more complex queries, more general queries. Yeah. Yeah, I think, yeah, we can do the same thing here. RIBI, but we need to assume that if those two products are in the same category or not, and then for them, come up with BI for them. We need to have a lot of simplifying assumptions. And we want to set it, I want to set it with my collaborators. Okay, this is the assumption we make, done. Alright, I better make my decisions already and then give it to them and then we can think on that. My only problem with RIBI is that It doesn't have outside option. Okay, we should come up with an outside option for this one too. Outside option. It is like maximizing revenue, optimal revenue. If you don't put any outside option, we assume consumer pays whatever we want. That makes the problem stupid. Outside. So if we come up with an outside option for this one, and the problem with DCG is that they do not assume any outside option. And they actually, DCG doesn't give us a user behavior model. Outside option, how user chooses. Alright, I think I will write down this stuff. Okay, if you have some time, let me also address Monzer's question. So Monzer said, what is the perfect data set to confirm the model? Alright, for that I wanna move everything and use the that's it. Action is this. Wow, the change so small. Okay, perfect. Yeah. So let's assume you can see it. I guess you can see it. Let me bring my own marker. I can choose whatever ranking I want. I can choose whatever ranking I want. The platform lets me to move the objects and everything, and we are assuming that we have this Ri B pi I thing. So I put product product 1 So I I put product I at top position, right? And I put product J at position 2 to the end. And we can see that for position 2, for any position from K2 actually, to K0, up to K0, item J is clicked and item I is not clicked. So RIB1 is less than RJBK. Alright? And for any position after K0, I better call them L0. Alright, K0, item I is chosen over item J, therefore RIB1 is greater than or equal RJBK. So we can say that here it gives us a bound for ratio Ri to Rj that it is less than BK0 than B1, which is less than 1. And on the other side, we know that Ri to Rj is greater than or equal Bk to B1, right? Bk to B1, and how big I can make this bound is K0 plus 1, so I can say Bk0 plus 1. Alright, so I put item J here. We want to find both R and B. What if I set item I at position 2? That's it, I equal 1 gives us this. Similarly, let's go, do you see that? Sorry. So K0 now let's say we have this. I set I at position 2 and I am changing J, and at, I don't know, K0 of 1, I should say this. Now it's item 2, I equal 2, but it's another pi, by the way. Gives us what? We are doing item J, and we have it at K0 2 switching. So for any K, that K is between K0 2 and 1, we have J is clicked, RJ, RJ B pi prime of J greater than R I B2, and K greater than K0 K2 plus 1. K greater than K0 2 plus 1, we have switched RJB KO2 plus 1, or sorry, K la 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 la. Here also K. Here K. Ri V2. So we have kind of Ri over Rj. Less than Bk. And what is the minimum on Bk? Sorry. Ri over Rj is B less than Bk over B2 for any k here, and because B is decreasing, or is it here? I cannot see it. How can you see it? Oh, you can see it. Because k is decreasing, we can say the minimum of it is KO2. KO2, and Ri over Rj is greater than or equal Bk over B2 for all k greater than this, which ends up be KO2 plus 1, the maximum lower bound over B2, and that's it. So by the way, we know that for KO2, so when we put the item at position 2, it gets less boost when it's up compared to when we put it at position 1. Therefore, we expect KO to be bigger than KO1. Why not, right? Actually, I can say no. How would I learn it? I don't know how I learned it. How I would learn it. So Munzer says you assumed in your model that there is this function R and B that is working like that. What is a perfect data set that confirms it? Or we can learn from that data set. What I had previously in mind is that, yeah, just suggest an R or B that makes sense. So from all of these inequalities, how can we find R and B, right? This one actually says Rj is greater than Ri. So definitely if I put J above I, they won't get click. By the way, I don't know why we need to learn R and J. Sorry, R and B. If I have this freedom to choose whatever I want, well, I just, first of all, this inequality tells us what is the order on I, what is the, I can have arc sort of I, R for the ranking. As my pi. Arc sort of this motherfucker. I mean, I don't, I just know R, I, yeah. I can have the sorting. Where should I find the function? I don't need to find the function. I don't know where this question is coming from. R and B. So we have them. Let's set the maximum R as 1, by the way. Is he saying that if it is a well-defined? Is it that is we are saying that even we can find R and B? Are there functions? Are there functions such that match this behavior? So we easily know how to sort them based on R. Alright. It's not very difficult. Sorry, how do we know that? So if j is above I, j is chosen. If j is below I, still j is chosen. Alright, there is one missing part here. What if we switch I and j, and for no k, j is chosen? So actually for each k, Ri Bk is greater than Rj Bk plus 1, and Rj Bk is greater than Ri Bk plus 1. What if this happens? That's true. Okay. What if this happens? And we cannot say anything. Ri over Rj. So therefore Ri over Rj will be bigger than Bk plus 1 over Bk and Ri over Rj. Bk and will be j less than what? Ri over Rj will be less than Bk over Bk plus 1. Well, this motherfucker is always greater than 1. And this motherfucker is less than 1 all the time. So you cannot say which one is which. You cannot even sort them necessarily. Alright. Then they are very close to each other actually. If there is no ranking that can separate I and j, what about a third element? Does a third element help? Maximizes I and j. Because this is a discrete set, right? We can have, like, what is the minimum, actually Bk over Bk plus 1, like what is the k that minimizes this? And the same k, so it is will be a number L, which is greater than 1, and maybe to 1, but we know that it is not limit into infinity, and this is 1 over L less than 1, and if you have R that is between L, the ratio of R's between L and 1 over L, we can have functions like that, and we have room for choosing R. So I don't know exactly what's going on with this answer, but I don't even know why we are interested in this. However, it is interesting if you have a good data set So let's assume there's always a k0. We assume exists k0, but it can be not the case. It is not the case that there is a k0. And we have a lot of constraints for Ri over Rj. That's what we wanted to say. Actually, this is kind of the simplest case. And we can choose R. We cannot even sort them necessarily. Well, it means that it doesn't matter. Sorting doesn't matter. They are so close. It means that they are so close that and homogeneous that sorting really doesn't matter. If they're that close, that's actually a very good point. We don't need to necessarily sort them based on. That's just a good thing actually. It says sorting. If two items are close enough, really doesn't matter which one is at the top, as long as they are close enough. As long as they are close enough, it doesn't matter which one is on the top. We can neglect that part. So that's actually nice to write down. We can sort them, and we have, let's assume now we can sort them. We have the best sort. Does it really matter to find function R and B? We're assuming B is decreasing. We're assuming B is decreasing. That gives us something. What we are saying is that is there any pair of functions R and B such that satisfy each pi click behavior? Alright, I'm not going any further on any of these notes unless I'm thinking like we're solving 5 problems at one time, which is not good. I rather write them down and then we pick one to go further. Yeah, I pick one to go further. Yeah, I cannot deal with 4 problems at one time. You need to choose one. At least for a while. Alright guys, I like to play some counter. I have to go do my shopping. Alright guys, hope to see you. Bye. Bye is there.